Hello student, in previous lecture I have discussed what is the signal flow graph. Okay, why we need this signal flow graph, like what are the advantages of signal flow graph over block diagram reduction, and after that I will discuss the elements of signal flow graph, like branches. The elements of signal flow graph are branches and nodes. Okay, then we have discuss how a simple equation is represented by signal flow graph. Okay, then we have discussed some terms of signal flow graph like node, branch, input node and output node. Okay, so today I will discuss the rest part of this signal flow graph. So let's start our discussion. So after input and output node, then the term is mixed node. Okay, so previously we have seen what is input node. Input node is that node those have only outgoing branch, and output node has only incoming branch. But the difference between input node and output node with the mixed node, in mixed node has both incoming and outgoing branches. Input node has only outgoing branches and output node has only incoming branches, but in mixed node they have both incoming and outgoing branches. Okay, so see this diagram in this signal flow graph. So here there are 4 nodes. One node is x1, second one x2, third one x3 and fourth one is x4. So among these 4 nodes, only 3 nodes are mixed node. Okay, so see here x1 is input node because they have only outgoing branch. Okay, they have only outgoing branch. But this x2 node, this x3 node and this x4 node are mixed node because see here x2 have incoming branch and also x2 have outgoing branch. Okay, same for x3 have incoming branch. See x2 have, this is incoming branch and this is outgoing branch. So x2 is our mixed node. See the next case, next node is x3. Same x3 have incoming branch and outgoing branch. Okay, now see the third node x4. So x4 has also incoming branch and outgoing branch. So these 3 nodes, that means x2, x3, x4 are mixed node and x1 is our only input node because they have only outgoing branch. Clear? Now come to the next term. Next term is transmittance. So what is the transmittance? Transmittance is the gain between 2 nodes. It is generally written on the branch near the arrow. So transmittance is generally, transmittance is the gain between 2 nodes. See, if we have a block diagram like this is our input signal R and this is our output signal C and the gain of the block is G. So if we want to represent this block diagram by signal flow graph, then the signal flow graph of this block diagram is, here this is 2 node, this is input node and this is output node. So input node is R and output node is C, and this node is connected by a line and this line is called branch. So the transmittance, here the transmittance is G because the transmittance is the gain between 2 nodes. So here two nodes are R and C, and this node, two nodes are connected by line, and this line is called branch, and the transmittance of this branch is the basically the gain. So what is the gain of this branch? This is G. So here this G is the transmittance. Okay. So if we consider this case, here transmittance is T12, X1 and X2, these two node, and these two node connected by branch, and the transmittance is T12. In this case, if we consider X2 and X3 node, then X2, X3 node is connected by this line, and the transmittance of this line is T23. And if we consider X3 and X4 node, X3 and X4 is connected by this line and by this line. Okay, so here T34 and T43 are the transmittance. Okay, now come to the next term. Next is path. So what is path? Path is the traversal of connected branches in the direction of branch arrows, such that no node is traversed more than once. Okay. Next term is forward path. So what is forward path? A path which originates from the input node and terminates at the output node, and along which no node is traversed more than once. See this diagram, this signal flow graph. Here there is only two forward path. Forward path is that path which originate from the input node. Okay, so and terminates at the output node. Okay, so if you consider this signal flow graph, so input node is here, input node is this R, and output node is C, and this node is connected in this way. This is our one forward path. So from R to C we are going in this way, or otherwise we are going in this way. Okay, so here there is two forward path. One is this and other one is this, which is shown by this red line, and second one is indicated by this green line. So here we connect means input node connected to the output node in two ways. First one is this, which indicate by the red line, and second one is this, which indicate by the green line. So what is forward path? A path which originates from the input node and terminates at the output node, and along which no node is traversed more than one. So clear what is forward path? Next come to the term forward path gain. Okay, so what is forward path gain? Forward path gain is the product of branch transmittance of a forward path. So forward path gain is the product of branch transmittance of a forward path. So see, if we consider the upper forward path means red one, so what is the forward path gain? Forward path gain is the product of branch transmittance. Okay, so here the what are the branch transmitted? If we consider, this is our input node, this is one node, this is second node, this is third node, this is fourth node, this is fifth node. Okay, and this is sixth, this is 7, this is 8. Okay, so what is forward path gain? Forward path gain is the product of branch transmittance of a forward path. So if we consider the first forward path, means this first upper one, so what is the forward path gain? Forward path gain is only the product of the transmittance. So here node 1 to 2 is connected by this branch, and the transmittance in G1, like 2 to 3, node 2 and 3 is connected by this branch, and the transmittance in G2, and node 3 to 4 is connected by this branch, and the transmittance of this line is G3, and 4 to 5 is connected by this branch, and the transmittance of the branch is G4. So what is the forward path gain of if we consider the upper forward path? So forward path gain is G1 into G2 into G3 into G4. This only the product of a branch transmittance. Okay, and if we consider the second forward path, then what is the forward path gain? Forward path gain is G2, forward path gain is G5 into G6 into G7 into G8. Clear? So what is forward path? Forward path is how we will go from input node to output node. Okay. So what is forward path? Forward path is how we will go from input to output node. Okay. So if you consider this signal flow graph, there is two way. By using this two way, we will go from input node to output node. And what is forward path gain? Forward path gain is the product of branch transmittance of a forward path. So if you consider this signal flow graph, there is two forward path, and the forward path gain of first forward path is G1, G2, G3, G4, and the path gain, forward path gain of the second forward path is G5 into G6 is G7 and G8. Okay, so forward path gain is the product of branch transmittance of a forward path. Next, come to the next term, loop. Next term is loop. So what is loop? Loop is the path that originates and terminates at the same node, and along which no other node is traversed more than once. Okay, so if we consider this is our signal flow graph. See this signal flow graph. Okay, and in this signal flow graph there are three loop. Okay, so first loop is this, second loop is this, and third loop is this. Okay, so here in this signal flow graph there are three loops. So what is loop? Loop is that path originates and terminates at the same node, and along which no other node is traversed more than once. So here, see, if we consider the first loop, then first loop is starting. So then see, the first loop is starting this node, and so here the loop is terminate at the same node. If we consider the second loop, here also this terminate this originate this node and terminate at the same node. If we consider the third loop, and again in this case the loop start from this node and terminates at the same node. Okay, now come the next term, self loop. Self loop, what is self loop? Self loop is that path originates and terminates at the same node. So here if you consider this is our signal flow graph, then here we have seen there are 3 loops. One is this, and third one is this. So among these 3 loops, only this loop is our self loop. Okay. Now come to the next term. Next term is loop gain. So what is the loop gain? Loop gain is the product of branch. Loop gain is the product of branch transmittance of a loop. Okay. So if we consider this is our signal flow graph, and here we have seen there are 3 loops. One is this, and last one is this. So what is the loop gain? Loop is indicated by L1, L2 and L3. There are 3 loops. That's why it is named by L1, L2 and L3. So what is the loop gain? Loop gain is the product of branch transmittance of a loop. To see the first loop, this is our first loop. So what is the loop gain? Loop gain is first loop gain is G2 into H2. If we consider this loop, then what is the loop gain? Loop gain is H3. And if we consider this loop, then what is our loop gain? Loop gain is G7 into H7. Okay. Now come to the next term. Next term is non-touching loop. So what is non-touching loop? Loops that don't have any common node or branch. So here you have seen, here there are 3 loops. That means this is L1, this is L1, this is L2 and this is L3, and these 3 loops are non-touching loop. That means L1 and L2 are non-touching, L2 and L3 are non-touching, and L3 or L1 are also non-touching. So see here you have seen this is our input node. This is our input node. This is our input node. Okay, input node is sometimes called source. This is our output node. Okay, so input node means it have only outgoing branch, and output node means it has only incoming branch. Okay, and this is the transmittance. A is our transmittance. And here this is X2. X2 is our mix node because it has incoming branches and outgoing branches. Okay, and X3 also mix node. This is actually X4. This is actually X4. This is not X3. This is actually X4. This is actually X4. So here X1 is input node, X3 is X1 is input node, X4 is output node. In between X2 and X3 are X2 and X3 are mixed node. And this is X5. That means here we add disturbance also. So this is X5 and this is also input node because they have only outgoing branch. Okay, and this A, this B, this D are transmittance. Okay, and forward path, how many forward path are there? There is, this is one forward path. This is actually X4 and this is actually X5. So this is one forward path and another forward path is this, from X4, X3, X4. And okay, and first forward path is X1, X2, X3, X4. And second forward path is if this is x5 and this is x4, second forward path is this x5, x3, x4. Okay, clear? What is input node, what is output node, what is mix node, what is transmittance. Okay, so today I will stop here. The rest of the part of signal flow graph I will discuss in the next lecture. Thank you.